PV module operation and maintenance guidelines for snowy regions. Cleaning or not cleaning snow. In most parts of Sweden, the general recommendation from installers is not to actively remove snow from PV modules. One main reason is that mechanical actions on the modules can invalidate the warranty. In addition, most PV installations are residential and located in the southern half of the country, where energy losses caused by snow are usually relatively small. Safety is another important consideration, as private homeowners are typically not trained to work on roofs, and the risk of injury must be taken seriously. However, in the northern half of Sweden, conditions can be quite different. During March, strong sunlight often coincides with significant snow coverage, which can result in annual energy losses of up to 10%. In such cases, snow removal may be justified. Flat roof installations are a common exception where cleaning is more often recommended. When planning PV systems on flat roofs, it is important to leave sufficient space between module rows so that people can move safely if cleaning is required. The roof structure must also be designed to withstand the combined load of both snow and PV panels, and the acceptable roof load should be calculated by the supplier before installation. Active cleaning methods. Mechanical snow removal methods, such as brushing, may sometimes be necessary, particularly if the accumulated snow weight poses a risk to the roof structure. However, these methods also carry risks. Cleaning can damage modules or scratch the glass surface, especially when ice has formed. There is also the practical issue of where to place the removed snow, which can be challenging in urban environments. For rooftop systems, special care must be taken to minimize the risk of personal injury. If snow removal is absolutely necessary, it should only be done using a soft brush and limited to loose snow. Scraping frozen snow or ice is strongly discouraged, as it can damage the module surface and reduce performance. Cleaning a buffer zone. Another approach is to remove snow from the roof area directly below the modules. This creates space for snow to slide off the panels naturally. By doing so, snow accumulation underneath and at the lower edges of the modules is reduced, which helps prevent damage to module frames. Reverse current melting. An alternative method that has been studied is the use of controlled electrical current to actively melt snow on PV modules. Research in Norway investigated the application of a controlled forward current in the range of 10 to 19 amperes to generate heat in the modules. These tests were conducted both in climate chambers and on operating rooftop PV systems covered with snow. The primary goal of this approach was to reduce snow loads on underdimensioned roofs before, during, or after heavy snowfall, and to prevent roof collapse. The study included calculations of both energy and economic payback using local electricity tariffs and taxes. The results suggested that it may be possible to recover both the energy and financial investment, and even increase revenue by restoring PV production. However, this approach requires careful control of peak loads and the use of weather forecasts, to ensure that the energy used for snow melting does not exceed the energy losses it is meant to prevent or cause higher monthly peak power demand.